scheme. So this was a portable system that we then took around to get the scenario builders to build their landscapes. Okay. The basic process was a 5-step process. They were defining what they were going to build, constraining or unconstrained, i.e. accepting the legislative restrictions or not, choosing then defining the no logging areas, and that effectively restricted the amount of land that they could play with. Apply the harvest systems to the land that was left in any means that they deemed suitable, either spatially or by attribute or by rule, and then calculate the landscape output. So it was an iterative process. They just kept going back and back until all the land effectively had been used up, or until they had met their scenario objectives. Initially, they were presented with a completely blank landscape. It's all polygon-based, 2D polygons. That just shows that there was no timber harvest applied at all. That's at the start. On a constrained scenario, you can see the amount of land made available has been restricted. The outputs at the bottom are still saying that nothing being generated. This was at the very start of the process. Example of a finished scenario is here. You can see that there are a number of harvest systems that have been applied, and that the wood and economic natural environment and immediate figure there at the bottom. And that gives people an indication as to how they were doing when we're building the scenario. Controller displays were standard form-based displays that enable the system to be manipulated. I incorporated those on the instructions of the scenario builders. Data collection was in Hobart, 15 groups, 26 participants. And we call them expert groups, where an expert is a participant with specialised scientific knowledge or an interest in landscape development. There were 4 basic categories: state and private timber production, forests and ecosystems, flora and fauna, and then the 2 specialists with beekeeping and ecotourism. I'll very quickly fly through some of the results we got. There were interesting techniques that they used to develop the scenarios. This one showed that they were primarily focused on a single harvest method. In this case, it's Tasmanian group selection. So that was quite a common method. People just focused on a single harvest type or harvest technique. Then we had the structural approach, where people focused at areas in the actual landscape and did something with it. Here they're using buffer zones around plantations to limit fire hazard. And then, like forest conversion, in this one they chose to convert the native forest back to plantation, but actually having a very high proportion of native vegetation, not logs. This was one of the lowest impacted landscapes. This went on. We're kind of running out of time, so I'll flip through the other scenarios to show you what came out at the end. The group sessions ran up to 3 hours to build 2 scenarios. We were concerned that people were going to get bored. This was not the case. They kept coming back and wanted to do more and more and more scenarios. We developed 25 in total, and we evaluated the system using a questionnaire basis. The response to the building was that people really liked it. They really liked the whole process of a group interactive session, that you could think about things on a landscape scale. They wanted to develop more scenarios, and they saw that the tool set was pretty useful as a teaching tool. In looking at the scenarios developed, the red areas indicated, but this is overall 25, the red areas indicated the maximum variation in the applied harvest system, which gives that indication of sensitivity of the landscape. So the next stage was for me was then to identify some method of visualizing this. How do we represent this and give this to the public? So we looked at particular areas, 3 specific areas that covered the boundaries between national park, state forest, forest reserve and state forest, and private property and state forest. And these areas were identified on the basis of both containing high variability content, i.e. the red areas, but also because the path between the forest reserve in the north, I'm pointing to the screen and you can't see me pointing to anything. The forest reserve in the north up here, and the private property here, there's a major tourist route here, so it actually, people were familiar with that area. So we defined these 3 areas as being key to the next stage, which was the visualization. That's for another paper. But decision-making with scenarios. In summary, the toolset and methods allowed the experts to develop multiple landscape scenarios with quantifiable outcomes. And the variability in the applied management systems indicate areas of contention. And those areas allow us to select visualization areas for the next phase. Okay.
Good. Thank you, Eric. We have time for some questions.
Did anybody actually understand what I was saying?
How slowly you adapted to your accent here. So you collected some data from experts at the start of the process, and did that then inform which factors you thought you needed to include in the model? And that's the first question.
Okay.
And the second question is, did you ask them at the end of the process if they felt that their views were adequately represented in the model that you built?
Absolutely, yes. The primary set of data that we used, anyway, on the maps, you see that it was quite granular. That's because the data was based on photo-interpreted vegetation types. Because of the large scale, the 66,000 hectares, there isn't really accurate maps as to what's where, because it's just such a large scale. And a high proportion of that landscape people don't have access to, there aren't even roads. So the PI type was the primary data set that we used to work with. With regards to building the outputs, the quantifiable components, yes, we had a lot of expert input into how best to represent the effects of the different forest management systems on different forest types, on different land. And at the end of the scenario building process, as part of the questionnaire, we did ask them if their objectives had been met in the scenario building process, and were they confident that what they had built met with their original objectives. And I think only one out of the 25 said that it didn't quite meet, because they wanted a different types of harvest systems that we didn't include. It was highly specialist. They wanted helicopter logging, which is single tree extraction, which is monumentally expensive. But anyway, so yes.
One more question. Yes.
With visualization, how do you plan to do that?
The next stage of visualization is taking these three areas, these three visual areas, and forming 360-degree panoramas of the areas for each of the scenarios. So we can represent the scenario both in a quantifiable output, a description output, an objective set, and a visual actual set. What I aim to do next is to take these and incorporate them into a web interface, and again go to the public. And then the public don't know which scenarios they're looking at, they're just classified as A to H, just generic tiles. And the public will then be looking at those and making judgments as to what scenarios they prefer. What's of interest to me is what components of the interface they actually use. Some people prefer visual, some people prefer map-based, some people prefer descriptive-based, etc. So all this information regarding the scenario is available, and it'll be quite interesting to see what people actually use in making their preferences.
All right.